But at some point, you got to leap over the edge and discover the unknown as you're falling off the cliff. Without creativity and a high tolerance of risk and failure, we're never going to actually emerge as a unique player in the market, offering something that's going to change the world.
Today, I'm joined by Christian LaRosa and Austin Thurman, the two founders of Rosotics. Rosotics is a metal additive manufacturing startup based in Mesa, Arizona. Although that may not be a household name yet, it very well could be in the future because their novel technology is redefining how manufacturing is conducted. Some of their target markets include air, sea, and defense, and they are about to print some of the world's largest metal structures ever seen before. We talk about how engineering, creativity, design, business operations, and general leadership all come together in one to form a great business. Hope you enjoy. How did you guys meet? What was the moment where you guys realized you guys have a connection in some form or another?
So this was around 2019, maybe. I think that might have been my sophomore year of my undergrad in aerospace engineering. And at the time, there was an AI club at ASU, Arizona State, where they had invited me to come speak about this idea that I was just forming. It was after when I was, packing up my laptop, packing everything up, when someone who was sitting there in the audience had come up and said, "Hey man, that was, a really good talk that you gave. There's someone I think you should talk to, someone you should meet." And I was like, "Oh, who is it?" Thinking it's, some professor or some AI name who's studying or teaching at the school. He set up behind the scenes kind of the first communication to Austin, and I think you could take it from there.
Yeah, so from there, I got a text from my friend John that there's this rocket guy, kind of this psycho dude talking about, at the time, drones and 3D printing and all this random stuff. And he said I had to meet him. So to me, I'm at the time going into school studying finance, and I never woke up in the morning thinking I want to go build rockets and work in deep tech or anything like that. But I knew that there was something ahead of me from this text that I got that was worth pursuing. So I remember I was supposed to meet Christian at like 6:30 on a Friday, and I was coming from Scottsdale and was running very late. And so once I got to school, I started sprinting from the parking garage, and I had to get to Hayden Library, which was probably a mile from where I was. And I was really sweaty. I texted a friend to meet me down outside of my dorm so I could grab a nice shirt so I could go and have a good little meeting. And so by the time I got there, I did all that work. I ran for so long, and Christian wasn't even there yet. So it was kind of funny. It was I didn't really need to work that hard to get there. But once he did arrive and once we talked, it was really an incredible experience because I think above anything else, it was the passion and the conviction from which Christian spoke that really sparked my interest. And sometimes people ask me, hey, like, how do you find a co-founder? Did you go to a networking event? Did you interview somebody? Like, how does that work? And for me, it was just from day one, I met with someone who was very passionate about what they were working on. And I just immediately wanted to join that mission. We didn't even formalize a work agreement or anything like that until years down the road. And I think that's a really good sign of, a partnership, especially in the early stages of a company, is just the desire to do something more together and, figure out the technicality of that later. And so really it felt like from day one, we just started working and never looked back. And then here we are years later after raising, lots of money and building our first products. And it's been a fun journey, but it all started from just, a good connection. And it's been a good relationship to this point.
For the average college student, I would say the traditional path is to, once you're done with high school, get your bachelor's degree, then either continue your school onward or seek employment. Was it ever in your guys' mind, whether growing up, high school, during college, that you would take an alternative route, more so during startup, and seek entrepreneurship? Or did that manifest once you guys came together?
There is this misconception that I was kind of like on the track towards this, natural entrepreneur. The reality is there is no real such thing as a natural entrepreneur. An entrepreneur is someone who is, in my opinion, made, crafted by the environment around them. And one of the biggest traits of that I've noticed is an indicator of someone who is going to do something quite different is the tolerance for pain. I never wanted particularly to be an entrepreneur, and I was never this stellar kind of student per se. I was studying a hard field, but I actually, after the first semester of my freshman year, out of high school, I actually left. I dropped out, and that was one of the most transformational decisions I think I've ever made. I went to live overseas in Italy, in the north of Italy, to teach English. And I was there for about 6 months, and then it was this other chance encounter. I was back in my hometown in Florida, just driving down the highway, and I got a call from ASU because I guess it was that time of the year they're going down the list. And they said, hey, if you're interested in coming back, we have a program called Quick Reentry where you can go back and pick up where you left off. My friend, I was sitting next to me at the time, probably thought I was out of my mind, but I was like, yeah, sure, why not? And that's the reason I came back to Arizona and picked up. And then following that, it was the next 3 years going into the end of my senior year, just before graduation, a semester out, where I dropped out for the second time because that was right when our first round of VC hit.
Yeah, and on my side, I never had the thought in my head that I'd be an entrepreneur. In fact, I was 99% sure I was going to go to University of Washington to study to become a doctor. My motivation growing up with a brother who has Duchenne muscular dystrophy was that I would go be a doctor and study to make an impact to his disease and improve that cause. And I remember there was this day, my dad was a great businessman in the liquor distribution world, and he had a bunch of people over one day. And I remember very vividly watching him talk to this room of maybe 30 or 50 people. And the moment he started talking, everybody looked and everybody listened, was just waiting to see what was he going to say next or what was the punchline. And that kind of stood out to me because it was the first time I really ever even considered the idea of doing something in business. Because I watched, I wondered, maybe I could have an effect on people like that. And actually, maybe I could do something in business and, develop something to a point where I can have an indirect impact on my brother's disease and create foundations and donate lots of money to the cause or make the drug more accessible to more people. And so that is still very deep rooted in my mission, but I realized I think there was a way I was better suited to undertake it, and it wasn't going to be studying medicine. And so I very quickly, I think at the last possible moment, decided to stay in state, go to Arizona State and study finance, which then within a month and a half, I met Christian. So it's funny how things like that work out and can change very quickly. And I too, like Christian, never planned to be an entrepreneur. I think a lot of my lifestyle and things I was involved with growing up had a big effect that kind of gave me the framework as a person to step into that role well. But I had no other prior experience running a company or anything really business related besides a couple internships. So Christian and I have together gotten to know what it means to be an entrepreneur, which, yes, involves lots of pain. And I think both of our tolerances for pain have had to expand quite a bit in the past couple of years.
So through learning more about yourself, more about how you work with each other, as you learn more about, the business that you're going into, a lot of entrepreneurs and early business owners question whether they are able to operate individually or if they should partner up. To my understanding, it seems like your guys' dynamic is, Christian, you bring a lot of the leadership and visionary roles that the CEO carries, along with engineering and innovation. Whereas Austin, you come into the picture and bring an understanding of business operations with regards to finance and organization. What would you say to the young business owners out there, the people still in college yet to graduate, or those not in college aspiring to run a business? Should somebody partner or not?
Yeah. This is a really important point. Sometimes you hear the phrase of, find someone that is not 1 + 1 = 2, but find someone that's 1 + 1 = 10, or someone that you can really scale together and grow up as people together. And I think one of the first things that stuck out to me about Christian when we met was that we were extremely different. Some people think to start a business, they got to find someone who's perfectly like them. They get along with super well in every single way. They can agree on every decision together. That's actually just a big pitfall. It's actually funny. I think every major decision that Christian and I have come across, we've started on the opposite sides of the spectrum for the way to kind of solve that. And together we end up working out to find what really is the best solution. And so Christian and I, we think very differently. We interact with people very differently. And I think that's super important, right? Because it creates kind of two sides of the same coin that I think have let us operate the business in a way that has been exceptional. I mean, I couldn't do the things that Christian can in the same way he can do the things that I can. And I think for any young entrepreneur, they have to realize that they do have strengths, but they also have weaknesses. And if they can find someone who's very good at their weaknesses, then you kind of have the right footing for growing a business from day one in a way that is not just going to be linear, but that could actually be exponential.
Yeah, I think on that point, an important point to mention is that this is a very popular thing. Entrepreneurship is hailed as kind of a kind of flashy thing. After influencer and YouTuber, everyone sees people like Elon Musk, Mark Zuckerberg, and they often attempt to kind of replicate what has worked in the past for those specific cases. The reality I had to learn very soon, which I think is a pitfall for many, trying to do something revolutionary, is that the reality is that there is no one who can advise you on how to build what's called a unicorn. A unicorn is defined by venture capitalists as a privately held company that is not publicly traded on the stock markets, valued at over $1 billion. Right now, the number of unicorns in the world is not high. It is very, very difficult to do. Out of every startup that you've heard of, out of every successful one, unsuccessful, most of them, the vast majority, are not even unicorns. This is an incredibly rare phenomenon. And because of that rarity, many who are trying to begin something think that, oh, I can go to a mentor or I can go to an advisor. The reality is there is no one who can advise you on how to do this. The road that we took personally, the road that led me to here as well, is a road marked with enormous, enormous sacrifice and gambles and risks that were 90% going to fail. As Austin mentioned, sometimes that means not logical bets that you're taking. I like to call them, at least internally, Sam decisions. Those are stubborn as a mule. And I call them those because they are where you are the only person in a room of 20 plus, even, arguing on one side versus the other. There are times in life where the things that excite you are not random, and you need to listen to that.
Within the business, as you guys collaborate, the purpose of a business is to create products and services that a market wants, that they're willing to pay a fair value for, that we would like to see bring a greater change to the world. How do you guys address the idea of having a product market fit? What type of initiative do you want to have on the world? And starting with that, could you explain Project Honeycomb?
So Project Honeycomb is buried deep in the Rosotics lore, as it's so called.
Yeah, this is like a hot ones question. Like you went deep for this. Yeah.
So basically, the beginning of all of this, we had an idea 3D printing, as it currently stands, is very centralized. That is, you have a printer, per se, with a head that deposits material. Honeycomb was basically the idea of inverting that. Rather than printing from one point source, you do it from many, collaboratively. This is a phenomenon known as swarm manufacturing. The only people really looking at that at the time were university professors, labs, nothing commercial. So we thought, what if you were to take, for example, a drone or a swarm of drones that each carry a small quantity of material and collaboratively manufacture in open air. Upon that realization, we took the core principles of Honeycomb, which is multi-point source printing, and packaged that into a fixed system. And that system traces, the system we're working on today, traces its heritage back to Honeycomb. It is a system that prints from multiple points at the same time, simultaneously. And as well, the kind of elephant in the room, figuratively speaking as well, is scale. Honeycomb is beneficial. It really was for one reason in particular, and that is you're detaching the limitation of the size of your printer from the size of what you can print with it. If you have an aerial system, for example, really the sky is the limit, assuming the system works. And the fixed platform could not sacrifice that. So how do you do that without taking the printer airborne? And the answer was you print from multiple points, as the airborne system was, but also you're able to move those points over great distance. The system we announced last year, it is the largest metal 3D printer in the world by capability that is commercially available as well. And that is for a very particular reason. We are undertaking the mission of expanding 3D printing into areas of industry where it could never touch in the past. I'll say point blank, we will never undertake the markets of printing parts or components or little prototypes of flanges or valves. We print the structures that no other system is able to print. Those are in aerospace, for example, the dome structures of the first and second stage tanks, as well as the tanks themselves, the fairings, the inner stage. We've looked into engine bells as well, and very, very tantalizing to me is some of the work we're going to be doing shortly in naval and maritime.
Yeah, and just to expand on that a little bit further too, there was a key inflection point that kind of transitioned us from Honeycomb to what Rosotics is known for today. And it was actually a chance meeting we got with Jim Cantrell down in Tucson, who's the co-founder of SpaceX. I'll save the story of how that happened, but it was just ridiculous that we even got the meeting. So many things had to just perfectly happen. And so we went down there, and our goal was just to share with him what we're doing, right? I think that's an important principle of pitching anything. You should just be excited about sharing something and hope that other people are too. And when we went down there, we talked to him for probably a half hour straight, just about what we're working on. And the first thing he says is, which was shocking to us, but he goes, you know, when you guys first walked in here and started talking about 3D printing, I was pretty upset. And we were like, oh, great. You know, this has gone phenomenal. And then he goes, but the way in which you guys are doing this is far different. Here's why I hate 3D printing. And he gave us this kind of introduction into what one customer, but this has rippled through the economy of many customers, but from his perspective, what he hated was that he bought a 3D printer one time, and it was basically an infrastructure investment. He had to give a huge portion of his factory up. He had to get a link to the power grid to fire up this laser that they were printing from, which is already a ton of money. And then once they actually printed something, they had to spend, you know, close to $1 million in total just getting heat out of the system. It was just a mess. It was something that nobody wants to touch, nobody wants to use. And this is a really big problem, especially when you're trying to print parts that are large, when you want to print structures. And so what he said is the process you guys are actually developing would eliminate all those things that as you just showed me, get this to the market quickly, you know? And that was really important for us to hear. That was really the first yes that we ever received from somebody. And it gave us a lot of validation in the direction of the printhead we were developing. And we wanted to be able to make that more accessible. And like Christian said, productize that printhead capability. And so that's what kind of cemented us from Honeycomb to Rosotics today in the printers that you see us kind of develop. And that's just, I mean, there's so many angles to which everyone has different definitions of large scale, as Christian likes to say. But for us, it's really anything larger than a refrigerator. We want to bring access to the large metal market. And I think providing capabilities to print in that way can accelerate the timeline of rocket development, vastly beyond what it's capable of today. Like, for example, one of our customers were talking about a simple dome structure for one of their launch vehicles would take a year for them to even receive. An entire year. And if everything else of the rocket was done, they still have to wait an entire year to be able to even test if that rocket works. And in the direction that the space economy is going, if you can only launch your first rocket in a year from now, and SpaceX is 10xing, 100xing over the years, no one's ever going to be able to compete in the space market. And so it's really important that the small players have the ability to really rapidly scale their production efforts and their testing efforts, which is really the key defining factor of additive manufacturing as a whole. But it's just never been available to people wanting large metal structures. And so that's where we step into the market, and that's what we want to provide.
To kind of leapfrog off that real quick, I think there's kind of a misconception as well as to launch as an industry. And we have to learn this very well in order to serve these clients. The reality is also that SpaceX is going to radically redefine the boundaries of access to orbit and beyond orbit when Starship is operational shortly. You're going to drop essentially the cost per kilo to low Earth, roughly one or more orders of magnitude. With that impact of Starship coming operational, what is going to happen actually is the Falcon 9, the vehicle we all know that lifts astronauts to the ISS today, that vehicle is going to be retired very soon, probably within the next few years, meaning there is going to be a very interesting hole in the market for small to medium lift payloads that may need a more dedicated orbit, a specific inclination, or a polar orbit, for example. I've kind of spoken with Chris Kemp of Astra, with the guys at Relativity, and some of the SpaceX guys, and the interesting thing is there is still a very serious opportunity in launch to fill that gap the Falcon 9 currently occupies. And I think there are going to be players emerging, like the Relativities, like the Rocket Labs, that are going to fill that gap. But what is missing is also that very, very, very high frequency of dedicated orbit. That is a space that does need to be developed still, and part of what we are working to help enable some of those mavericks I'm working on.
Absolutely.
So you guys not only have the ideas, but you're launching prototypes, you're doing a lot of tests, you have a lot of people on board helping out to facilitate this whole process. Where does creativity fall in line with this? Because Christian, you're coming at this with a deep technical knowledge of engineering and those processes. And Austin, you're coming at this from, the operational mindset. Where does the deep technical operations merge with the creativity? Because, even just recently this summer, I found out about the power of induction. Mm. I was traveling, and it took me probably 20 minutes to learn how to use a stove. God, why is this not heating up? And I turned the max thing, and I'm touching it. What's going on? But to my understanding, when it was Project Honeycomb era, the big problem was there's no way the FAA is going to let us launch these drones that can print by using lasers or plasma, but maybe we can use induction. So if that's a constraint, how did you guys approach that creatively?
Yeah.
So, yeah, when it comes to Honeycomb, these were the first kind of ideas we began to form, and we knew I'm actually an FAA licensed drone pilot as well, and I knew there were things that could fly and definitely could not fly. A laser, a plasma, a powderized metal is quite dangerous in and of itself, would never fly. So what happened was, and this is kind of the story of the beginning of the induction approach, we knew that something different was going to be necessary, at least for Honeycomb. And looking, I kind of spent a summer of my life just uncovering every rock, every stone, everything I could find, until I came across a kind of electric approach that some lab had been doing in academic research, and they kind of circuited the print bed and then the metal sitting on it that's being printed, and used that to spark an arc between to melt and liquefy the material. And I got a hold of them, and this is one of the power stories I like to say of how we became what we are. I got a hold of this group that was working on that, and this academic research team. I was like, this could be something here that you guys have found. Can I learn more? And this was one of the defining moments of my life. I was told, and I remember this to the day. I remember this word for word. I was told they would not so much as take a call with me unless it was to the tune of $100,000. And so I looked at how a different way of doing it, still electrically, but a different way of doing that process altogether could be made. And I found rapid induction printing. And the namesake, the acronym, also came from rest in peace, because I don't believe any entrepreneur, anyone even who is working to further an industry, should be treated in that manner. And that forms part of the ethical basis that I live upon.
Yeah, and that move away from the laser does enable scale. I mean, the laser itself just offers so many issues that I think people turn a blind eye to because of the promises it has of accuracy and precision. So the reason why moving away from a laser was important for us, because it allowed for multiple things. On one hand, back to Project Honeycomb, what was true is that you couldn't put a laser in the air. What's also true is that for a large-scale system, we didn't want that to be boxed, right? We've already talked about earlier, the size of the printer was the limitation of what you could do. We don't want a box. And so if you take out the box, then you have just a laser in open air. Well, that's not safe either. So it doesn't matter if it's in the air, if it's on the ground, that is just a huge safety hazard using a laser. The next problem was just the actual energy use. Lasers are inherently very inefficient. And for these kind of larger structures that people have been trying to print, it's almost the difference of hooking up to the power grid to get to use. That's infrastructure. That's not a product. That's not easy to implement. And when we move to induction, we can literally power our system using 5 to 6 light bulbs worth of wattage. It's that different. It's just our whole system plugged into a basic 240 volt outlet that pretty much any facility is going to have. And so that's a big deal when it comes to offering scale in a way that's actually easy to implement. And also to go back a little bit too, talking about creativity, it is the basis of everything that we do. Everyone talks about core values. For some people, it's just a poster on the wall. But for us, with every angle of any decision, for every hire, whatever it is, creativity has to flow out from just someone's innate curiosity. And that curiosity is absolutely essential because we are doing a novel technology. And there are some historical things you can look to and some research that's helpful. But at some point, you got to leap over the edge and discover the unknown as you're falling off the cliff. And without creativity and a high tolerance of risk and failure, we're never going to actually emerge as a unique player in the market, offering something that's going to change the world. And so creativity and curiosity fuel every bit of the technical operation, from the person that walks in the room to the decisions we have to make.
So there's a lot of complex ideas for the common person, which I consider myself to be in this context. How could the common person, swallow this? What difference is this going to make at scale for the day-to-day person?
One of the quotes that I kind of really internalize from some of the work I've done before any of this as well is JPL's motto, which is to dare mighty things. It is far greater to try and succeed or fail than to not try at all. And the mighty thing that we believe had to be done was no industry should be locked out from innovation. In 3D printing, we all know the small to medium scale has exploded. It's highly commercialized now. You've got any one of 2-3 dozen 3D printers you can order on Amazon. In metal, it's a bit tighter. You got to go to some specific groups like Markforged, Desktop Metal, or even some other niche names. But beyond that, it gets a lot more niche. When you grow scale, the options fall down to half a dozen, and then to 3, and then maybe 1 or 2. For kind of context, in naval, the application we're undertaking now for a world record attempt, the largest 3D printed object of any kind, will be a submarine hull printed over at Falcon Field Airport. And for that application, I was quite surprised to learn as well that it's not just that it's rare that there is metal 3D printing capability at that size. It's that it is almost non-existent. Right now, we are the only group in the United States with that capability to 3D print that kind of an object in the material that we're seeking to do it. And I want you to think about that for a minute. I'm 25. Austin's 23. Some members of our team are even a little younger than that. The fact that that is the state of certain areas of these markets, and that we may actually be the only ones working in that application, I think is telling. We need to. If it was not us, working in industry would be up every night. I would be wired, knowing that if we weren't doing this, it simply would not exist. There would be nobody printing those parts of submarines or rockets or anything of that size for that matter.
Yeah, and a little bit more on the common person too. Christian kind of touched on it, that we are so young, and there's some visibility that comes with that. And what's important to us is just the idea that people are much more capable than they think, and not just to consume, but to produce and to build and to create something. And even like you had a hand in that too. When you shot a video for us, you were part of the creation in the building of that, and we get a lot of comments from people just in Mesa, Arizona, who are saying, hey, I heard about you guys on the news. Like, this is crazy that this is in our backyard. And it's just that those little bits of inspiration that begin to spread around. We hope that it makes people begin to wonder for themselves. If we at Falcon Field Airport in Mesa are building what we believe is the best way to build, can that person experience a little bit of that in their life as well? And maybe it's not, taking on the world's largest metal 3D printers, but everyone's got something that they want to build, something that's in their head that they've maybe put off for their whole life. It could be a kid starting a company, or it could be someone who's 50 and just wants to, mess with their hands a little bit and build something. But that image and showing that we are capable of doing more than we believe, and rising above ourselves even, we are so young. And to have that kind of support and build that inspiration is very important to us. and we care a lot about the effect that we can have on the community in that way.
Yeah, people really need to know that things, even this difficult. I mean, we work at the outer limits of what can occur in material science at thousands of degrees Celsius. And that's before we even mention the rocket part or anything else. People really need to know that these difficult things you can do this. Like, one of the moments that really burned itself into my memory that I never forgot was when we were moving into our hangars over at Falcon, and we were setting up the first prototype of our printer, which is quite a large machine. It's as tall as maybe 2 or 3 of me standing on each other's shoulders. And we were having these IT guys coming in and wiring some stuff up, doing some stuff to the building. And one of them had brought his daughter in to work for the day, I guess. And I just thought for a minute, this is a rare thing. You know, this is not something normal that we're working on. And those are the moments, at least for me, that you can often remember for the rest of your life. So I actually took the contractors over. I let her open the big hangar door, giant thing lift off the ground, and then you see all the jets outside. And the guy afterward, he came to me and said, I know what you're doing, and she's never going to forget that. And I think those opportunities are there a lot more than meets the eye, even with people who are older. You know, one of our guys, brilliant. He is one of the brightest people I've ever met. Before this, he'd been looking for something really good to sink his teeth into, and he didn't know just how good he was. And when you see that kind of awaken inside of a person, you know that they are never going to look at themselves the same way again. And that's personally the most satisfying thing in my mind of the last several years, seeing happen in front of you.
I'd like to zoom out and broaden the scope. There's the idea that whether it's in a decade or a generation, that new technologies emerge and that there's deep infrastructure laid out so that the next generation is afforded the next step of evolution. You could say that, you know, from the agricultural revolution to industrial and on, more recently and more relevant, I'd say the internet and instant communication has afforded us modern social media, which influences marketing, purchasing decisions for consumers. How do you guys approach the rapid change? Because we've seen automation and artificial intelligence really hit the software side of business. Now, I could see that what Rosotics is doing by more or less automating hardware. What do you guys think of for the future? Where do you think we're going with regards towards our next step in evolution?
We're moving towards a very unrecognizable world than science fiction had predicted. It is not going to be as simple as, say, there is a super intelligent AI that we have to worry about or not worry about, maybe a golden age it could be. That was, I would say, pre-GPT assumption of the emergence of AI and what's called a singularity. In my opinion, I think a lot about deep learning and data mining. I believe that the world that we are heading towards is a hyper-accelerated world. There's a community I subscribe to called EAC. This is effective accelerationism. Kind of the idea that you have to build, you have to create and do it fast in order to alleviate the problems in the world. And we've seen many of them recently. What happened in Ukraine, what happened in Israel. A world of stability, a world of abundance, and personal freedom and liberty is defended by not sitting back and watching the world change around you, but protecting the parts that matter. And in my personal opinion, I think manufacturing and defense is a very important part of that world. And AI is going to change what that landscape looks like quite a bit.
Yeah, and even to narrow that scope a little bit to just how we approach the day-to-day operations. To your point, in the internet era, we saw software companies and really the SaaS business model absolutely explode and go crazy. And the motto, obviously, at Facebook is move fast and break things. And that's been true for every software company. It's about how fast can they iterate, how fast can they update and put things out and as a live service. And I think hardware is starting to wake up to that. And so we're trying to adopt as many of those software principles as possible. Like right now, for example, the Apple standard is one new phone a year. Obviously, they have a lot of different hardware products, but that's going to have to increase. And even as an early stage company that is limited in funding, limited in headcount compared to what we will be eventually, we still have to adopt that principle. And it's even into our design cycle and even our patent behavior. You know, we kind of take the philosophy that even the stuff we were working on a month ago is already so outdated and obsolete to what we're doing today. And that's how fast we have to iterate. And that's in response to the market. That's in response to AI and all the things happening around us. And so that's really important to our day-to-day operation. And then also, like Christian said, not sitting back and watching, but really having a hand in what's going on. And so not much I can talk about on here, unfortunately, but there is a lot that we've thought about in reference to AI and how that plays into the process of manufacturing down the road. And there's some pretty incredible ways that might happen faster than we even anticipate, that we're going to be implementing that into our system, so really have to stay up to date with it. And the better we can do that, then we will have a hand in what's happening, and we won't necessarily be defined by everything else that's happening around us. And we believe that our vision is important enough to be, have a really large say in what's going on in the world around us.
I think that what you guys are doing is very involved with that evolution. And I think that you guys are doing a very interesting thing for people that have a deep understanding of the industry, but also to those that are just learning about the industry. So I just want to say that I am very curious to see what you guys come up with, and I anticipate your growth. And I want to thank you very much for being here. This was awesome.
Sweet. Yeah, man, that was great.
Love you, Reece.
Love you too, Christian.
Thanks, Reece.